Section 2. How Elements works. Elements provides a technical solution to problems blockchain users face daily: transaction latency, lack of privacy, and risk to fungibility. Elements overcomes these problems through its use of federated block signing and confidential transactions. Unlike the Bitcoin network, the process of block signing within Elements is not reliant on dynamic membership multi-party signatures and proof of work. Instead, Elements uses a strong federation of signatories, called block signers, who can sign and create blocks in a reliable and timely manner. This removes the transaction latency of the proof of work mining process, which is subject to large block time variance due to its random Poisson distribution. The federated block signing process achieves reliable block creation without introducing the need for third-party trust. Elements can run as a sidechain to another blockchain, such as Bitcoin, or as a standalone blockchain with no dependencies on other networks. When used as a sidechain, the strong federation also contains members who enable the secure and controlled transfer of assets between a main chain and an Elements sidechain. The controlled transfer of assets is called the federated two-way peg, and members who perform the role of asset transfer are called watchmen. The processes involved in the running of an Elements network and the roles of the participants in the network are important to understanding how Elements works. Whether implemented as a sidechain or a standalone blockchain, Elements makes use of strong federations of block signers to produce blocks. Strong federations. Elements uses a consensus model proposed by Blockstream, called strong federations. A strong federation does not need proof of work, and instead relies on the collective actions of a group of mutually distrusting participants, called functionaries. The roles a functionary can fulfill within a strong federation are block signers and watchmen. Block signers are required if you run Elements in either sidechain or standalone blockchain mode, whereas watchmen are only required in a sidechain setup. The actions a member of a strong federation can perform are split between two distinct roles in order to enhance security and limit the damage an attacker can cause. When combined, the roles of these participants allow Elements to deliver both rapid block creation, faster and final transaction confirmation, and assured transferable assets, that is, pegged assets directly linkable to another blockchain. Block signers. A blockchain like Bitcoin's is extended when anyone forming part of a dynamic group of block signers extends a chain by demonstrating proof of work expended. The dynamic nature of the set introduces the latency issues inherent to such systems. By using a fixed signer set, a federated model replaces the dynamic set with a known set multi-signature scheme. Reducing the number of participants needed to extend the blockchain increases the speed and scalability of the system, while validation by all parties ensures integrity of the transaction history. Federated block signing consists of several phases. Step 1. Block signers propose candidate blocks in a round-robin fashion to all other participating block signers. Step 2. Each block signer signals their intent by pre-committing to sign the given candidate block. Step 3. If the given threshold for pre-commitment is met, each block signer signs the block. Step 4. If the signature threshold, which may be different from that of Step 3, is met, the block is accepted and sent to the network. The strong federation has reached consensus on the latest block of transactions. Step 5. The next block is then proposed by the next block signer in the round robin, and the process repeats. Because a strong federation's block generation is not probabilistic and is based on a fixed set of signers, it will never be subject to multi-block reorganizations. This allows for a significant reduction in the wait time associated with confirming transactions. It also removes the incentive to mine for profit, i.e. the block rewards, and replaces it with an incentive to productively participate in a network where all participants have the same shared goal. ensuring the network continues to function in a manner that is beneficial to all. It does this without introducing a single point of failure or higher trust requirements. Elements as a sidechain. Watchman and the Federated two-way peg. When run as a sidechain, some members of the strong federation have an additional role to fulfill, that of the watchman. Watchmen are responsible for the transfer of assets into and out of an element's sidechain, processes known as peg-in and peg-out. In order for a sidechain to operate in a trustworthy manner, it must allow participants to verify that the supply of assets is controlled and verifiable. An element sidechain uses a two-way federated peg to enable the two-way transfer of assets in and out of an element's blockchain. This satisfies the requirements of provable issuance and interchain transfers. The federated two-way peg feature allows an asset to be interoperable with other blockchains and representative of another blockchain's native asset. By pegging your blockchain to another, you can extend the capabilities of the main chain and overcome some of its inherent limitations. At a high level, transfers into the sidechain occur when someone sends main chain assets to an address controlled by a multi-signature Watchman wallet. This effectively freezes the assets on the main chain. Watchmen then validate the transaction and release the same amount of the associated asset within the sidechain. The released assets are sent to a sidechain wallet that can prove claim to the original main chain assets. This process effectively moves assets from the parent chain to the sidechain. In order to transfer assets back to the main chain, a user makes a special peg-out transaction on the sidechain. This transaction is checked by watchmen who then sign a transaction spending from the multi-signature wallet they control on the main chain. A threshold number of participants in the federation must sign before the main chain transaction becomes valid. When the watchmen send an asset back to the main chain, they also destroy the corresponding amount on the sidechain, effectively transferring the assets between blockchains.